Hello everyone and welcome back. In the last episode we added our little spring joint as you can see here, and in this episode I'm gonna add a reverse force joint which the force will be decreasing. Well, it's kind of like the spring joint when it's shrinked, like the spring joint I mean. And the reverse force joint will act like that the circle is always pushed apart from the other object. Well, or actually both objects are pushed apart, but the farther they go away, the more the distance increases, um, the less force is used to push the objects away. Okay, and yeah, that's going to be a little bit more challenging than the force giant, but I think it's fine. Yeah, let's jump to Visual Studio and implement our reverse force joint. For this, of course, we're going to add a new file, and this will be reverse force joint.js. And this time I'm gonna add this joint directly to Java, to the main HTML and include it. The reverse force joint, there we go. And now in the reverse force joint file, I think I can just copy everything I have from the force joint and paste it in there and rename some things. Here, I'm gonna rename it to reverse. It's going to have a strength, a connection of course, and a max effect distance. This distance will say at which distance there is no force anymore. And it's not going to be that when this distance is arrived, I mean when this distance is reached, then there will be like before that distance full power, and after this distance is reached null power, null force. It's going to be like linear. It's going to be linearly, just step by step, a little bit smaller, and so on. Yeah. So let's add that too. Also, I want to add that force halving to our force joints. But I'm gonna do this later. Here in our update connection A, we can remove this line, and the other lines we can we need to use the other lines. Yeah. And now we are going to calculate a force magnitude again. So force magnitude equals to, this time I'm gonna say math.max, and we're gonna have a maximum force between 0 and this dot max effect distance minus distance. All right. And of course I need to get the distance too before the normalization. So that distance is direction dot length. All right. Then we have our if statement with the rigid body again. So if this dot rigid a dot is kinematic, I'm gonna return. I think, did we do this in our spring joint actually? No, we didn't do this either. Okay. Yeah. I think I'm gonna, because we don't need to do this if this body here, if rigid body A is actually a kinematic, we don't need to calculate our own force. So we can just skip this part then. But I'm gonna do this at the end of the episode. All right. Yeah. If we are the object and we are a kinematic body, then we just return the method. We don't need to calculate anything. Then we have here our force magnitude. And now I'm gonna calculate the force halving. And yeah, this is just again our if statement. I'm just gonna copy this one. I'm not going to calculate anything. But this is now used to calculate the force. And this is done by calling this dot Ricci A at force at point. And we say anchor pos. We scale this force by the direction. The direction is normalized with the force magnitude times the strength times the force halving, and this time we're gonna say -1. All right. I think I did, yeah. Okay, and then I'm gonna say if the distance, this is just for drawing now, if the distance is smaller than this dot max effect distance, I'm gonna say this dot joint connection dot color is equal to blue, and else it's going to have the color of orange. Equal to orange. There we go. And now we can copy all the code again, paste it in the connection B, and make sure everything's right. There we go. Change this one to B. This is good. Direction needs to be anchor A position minus anchor B position. Distance is also fine. The direction normal is also good. Force magnitude, this is also fine. Force halving is also good. Then rigid body B at force set point, anchor A. Oh, I think I made a mistake. Here this needs to be anchor B position and this needs to be anchor A position. Then scaling with the force magnitude and -1. That's right. This is also fine. Yeah, that's it. Okay. Then I think I can go to the spring joint and just add these things here too. So just add it like this. And if that's a rigid B, then return. And then the same thing for the force halving, for the force joint. If that's Richie A, then here Richie B. And then we have the force halving again. So copy this. There we go. It's our force halving. I think I'm gonna put this right there. And this one also right there. And this force halving will be used instead of the 0.5. Okay, then we have this one, and the spring joint is also updated. And now we can use our reverse force joint. Then go to the simulation. And here we're just replacing the new spring joint with the reverse force joint. We have the joint connection again. Then I think the strength will be 2 this time, and the max effect distance again. I think I can set it to 300. All right, good. Yeah, refresh, save, refresh, refresh the browser. I mean browser, not browser. And now, yeah, of course I need to go to the browser. There we go. if I drag the circle to the rectangle, it should now trying to push the circle apart. And it does. Cool. All right. I'm gonna increase the strength a little bit. Let's say I'm gonna say 6 instead of 2. Refresh. And let's see what's going to happen if I drop it like this now. All right. Yeah. Awesome. Cool. Yeah, that's our reverse first joint. In the next episode, I'm going to show you how we can, yeah, it's just a flag that objects won't collide with each other, basically. And after that, we are finalizing our physics engine with 2 more joints, with the fixed joint and the hinge joints. All right, then see you there. Bye bye.